Awesome. So thanks everyone for being here and giving us the opportunity to talk about something that we really looking forward to present to you now, and that's the topic of bringing digital twins into the vehicle with Eclipse Ibeji. And we heard it just briefly now. This is a presentation done by me, Hans, Christian from Mercedes-Benz, and we have Ash also from Microsoft, who is in the States currently and will present from there. So our agenda, quite clean, I guess. We will focus firstly on a little bit on the topic of what is a digital twin and why is it useful. We will then introduce Ibeji to you. We will show a demo which we have recorded because of the demo gods, and then after some next steps we will be happy to take your questions in the Q&A. So first things first, what is a digital twin? I think most of the people here know it, but I think for the sake of completeness it's good to waste some words on that. Basically, a digital twin is a digital model of a real product, service, system or process that for the sake of practicality can be seen as an indistinguishable digital counterpart of that service that can be used for simulation, for testing, for integration purposes or for monitoring. So a quite handsome thing to have actually and to have in the car. Why do we need a digital twin, or what purpose does it serve? There are a lot of different purposes that a digital twin can actually serve in the vehicle as well as in other domains. I guess one of the first points to mention here is data cohesion. A digital twin can be a central part in a distributed, otherwise distributed system where data and controls from different sensors and different actuators that are otherwise distributed in an environment can be aggregated or centralized accessed in one point, making it a unique opportunity to just access it in one area. You don't have to swarm all over the place to find the proper things. You can just use the digital twin. So it makes it a lot easier for software systems to interact with the otherwise distributed sensors and actuators in the car, for example. This also leads to the second point, mirroring things in the cloud. If we are thinking now in terms of vehicles, it could be quite handy if you not only have the digital twin in the vehicle where you can interact with it to, for example, change some states. It could be also interesting to mirror that digital twin into the cloud to maybe actually offload some of the compute from the vehicle into the cloud to give the owner of the car or someone else still capabilities to interact with it, to read data from it or to change states like open windows in a hot summer day. The third point I'd like to mention is that a digital twin can help with rapid software development, because if the producer of some information, the one who creates the hardware and the firmware, the sensors and the actuators, and the consumer of that agree upon a contract upon which they want to interact, a digital twin can be used as a abstraction layer between both parties, where then the consumer can follow a contract-driven development approach to basically just disconnect the software, or disconnect those dependencies, write the software in a faster way, because maybe the hardware and the firmware development is a little bit slower or just has another life cycle than the software. And lastly here, I guess it's also nice to mention that a digital twin can be very interesting for real-time intelligence, because what I said with data cohesion, it somehow brings all the different sensor readings together centralized in one place where it can be accessed. So that makes it uniquely interesting, let's say, for data streaming, where you want to then derive knowledge based on the streamed data you actually can read. That on the theoretical side. Now let's talk a little bit more in the concrete side about digital twins in this term with Ibeji. And for that, I'm happy to hand over to my colleague, Ash.
Thanks, Hans. Okay, so let's talk about Ibeji. Ibeji is an Eclipse SUV project that is focused on the advancement of digital twins in the vehicle. It provides a platform. The vehicle's hardware capabilities can be offered up as digital twins, and applications and services in the car can actually interact with those digital twins to utilize those capabilities. It's only meant to be run inside vehicles, not the cloud. So Ibeji is meant to be have a very small footprint, okay? And we don't expect that it has to scale up to a very large size. And the design is based around that. There's also a focus on interoperability and openness with Ibeji. The idea here is it's a platform. We want multiple protocols to be used. We want data modeling from various data modeling ideas to come in, and people to basically use their own data models and so forth. And we want this to be a community effort. And then finally, it's a proof of concept. This is not a product that you could use in a production environment today. The idea is that it's to basically sort of figure out what a digital twin in the vehicle should look like and play with that and get ideas around it. Hopefully one of these days will be productized, but that's not in the books at this point in time. Can we go to the next slide, please? Okay, so with the Ibeji, there's a couple of sort of technologies that it depends on. One of these is D2DL, the Digital Twin Definition Language. It's a language initially created by Microsoft, but although it was created by Microsoft, it's meant for use and ownership eventually by the community. So there's standards efforts and open source efforts at the moment that are underway to try to make it more publicly used, right? Rather than something that's a proprietary standard, okay? And on the standard side, the Digital Twin Consortium is actively involved in trying to standardize D2DL. And there's also work at the moment where they're trying to make D2DL compatible with the W3C's thing description standard. D2DL to date's been used for several different ontologies. Here's just a small set of them: smart buildings, smart cities, energy grids, and manufacturing. The three of the most compelling benefits of D2DL is that it allows the digital twin to be represented as a graph. And that's really important as we're starting to compose and build things, okay? And also navigate, the actual data. It also allows you to specify not just data, but controls as well. You can actually have, digital twins can have operations that can be invoked, all right? And then finally, it allows models to be specialized via inheritance. And that's important because, you want, sort of common base that everyone knows what it looks like. And then you can add to that and specialize and provide vendor-specific features and new features and so on. Okay, let's go to the next slide. All right, so we talked about D2DL, okay, and it's meant to be used in order to define our digital twin models. And what do I mean by model? A model is synonymous with a type or a class, okay? And all the digital twins in the vehicle will have their own model, okay? For example, this is the model for a vehicle, and it only captures the top level of the vehicle. There will be other models for other digital twins in the vehicle, like seats, cabins, etc. And so with this one, if we just have a quick look at it, I'm not going to go through in too much detail, but you can see if you see the ID field up the top, that's the actual model identifier for this particular model, all right? And it's meant to be unique to this model, right? And it's also version. The one there represents the first version of it. It has a property vehicle identification, and it also has a relationship and here with the cabin. Okay, so you can start to see the graph side of it coming out already through the relationships. In addition to properties, we can also provide commands, but I haven't provided one in the example simply because there was enough room on the slide. Okay, can we go to the next slide, please? The digital twin data exchange format. So we've got this language for defining a model, but then the things that's defining, what do they look like when we're conveying them between different software components? And we need a digital twin data exchange format for that. We don't need one, we can have multiple ones, but we need at least one to start with so that when people are on board to Ibeji, they can quickly on board and start using that, right? And so the one that we came up with is based off of JSON LD. It's a derivative of JSON, and it's the thing about JSON LD that's very good for is actually building and representing graphs. It also has the ability to associate the data with a particular type, which is our model ID, okay? And also to give the data some sense of identification. And you can see that through the @ID keyword in this example. So this, the actual data model that we looked at in the previous slide, this is the data exchange format representation for it, okay? And this is only a simple vehicle, right? I didn't have enough space to add all the different parts of vehicle identification, like model year and so forth. The other thing too is this one is actually based off of VSS, but you could base, just going back to the models, you could actually base your digital twin models off of any schema out there, Sensorus, VSS, whatever, okay? We don't prescribe with the Ibeji which schema that you use to base your digital twin models off of, okay? And you could bring your own. That's totally fine as well. And building up your ontology, which is the collection of digital twin models, is actually part of the work as you onboard to Ibeji, all right? And you don't have to build it. You could use one that's already defined as well. That's fine too. Okay, can we go to the next slide, please? Okay, so we've talked about some of the technologies that it uses. Let's talk about Ibeji's architecture now. So the core of the Ibeji architecture is this digital twin app server. And with the digital twin app server, it can host multiple digital twin services, all right? In the initial architecture, there's just one digital twin service, the in-vehicle digital twin service. Sorry for there's a bit of a typo in the name here. And what that service does is it allows to map model IDs to, it allows us to map digital twins. It allows us to map digital twins to their access information, all right? And in this instance, the actual, there's a find by ID operation on its interface, which allows you to take a model ID and then actually find the access information for all digital twin instances that can provide that, okay? And so we also have in this architecture, digital twin provider. And what that is that's basically a role that the hardware side of things takes, right? Where it basically actually offers the digital twins that it represents and registers their access information with the actual digital twin in-vehicle digital twin service, okay? So it registers its digital twins access information, right? So that then another role, the digital twin consumer, can then come and first find those by interacting with the in-vehicle digital twin service, and then interact directly with the provider, okay, in order to utilize those digital twins that it needs to use, all right? Again, the consumer and the provider are roles. They're not components, all right? the consumer is a role that an application or service may take, and we can have a lot of them. And we also have the idea of having lots of providers as well, representing various capabilities inside the vehicle. Okay, and we also expect that you can have redundancy with providers too. Multiple providers can provide the same digital twin, all right? And that's perfectly okay. All right, let's go to the next slide. Okay, I'll hand it back to you, Hans.
Thanks. And what we can observe now in a few seconds is actually the interaction between Ibeji, a provider, and the consumer, where the consumer is a vehicle massage controller, which we saw here on the right side. On the provider is the actual massage seat. But Christian, then over to you.
Hello and welcome to the demonstration of Ibeji with a seat. I want to show you why we choose a seat. So the seat gives comfort while driving, and it can lead to stress reduction if the seat is comfortable. Additionally, we have the ability to give additional functionalities like massage or heating and cooling while driving. And the functionality is not limited, so we can extend the functionality. Now let's give me a short overview how Ibeji acts as a digital twin. So the seat itself registers its capabilities at Ibeji, and any massage controller or seat controller can request the capabilities and gets a response. This response can then be used to further interact with the seat itself. Now I want to show you how this is implemented. So I have here an overview of the currently underlying architecture. We have the Ibeji highlighted in green and layer val. You can assume the interfaces are functioning as shown on the sequence diagram before. So Ibeji can hold the information of the seat capabilities, which are here demonstrated as a layer val, so an abstraction layer or a driver in the seat. And the massage controller can then request the functionality and send the instruction as seen before in the sequence diagram directly to the seat itself. Now let's dive into the code. On the right side you have a window that will later show you the bubbles in the seat. Now let's start Ibeji. We see Ibeji start itself up with our chariot, and then we register the seat at Ibeji. You can see up in the Ibeji window that the seat is registered, and then later the controller requests the information of the seat and gets it. You see it also in the middle Ibeji window. On the right now you see the bubbles, and let's start a massage sequence. So you see the sequence is running on the seat and the command was sent. It goes up on the right side and down on the left side. So it's now let's assume we have a change of the seat, and now we have more and additional massage functionalities in the seat. So again, we start the same sequence, and it's really the same sequence. Everything is the same except for the seat, and it works as intended.
So yeah, you saw a short demonstration with a hardware exchange, which was not really hardware, it was the driver and the theoretically hardware that we exchanged. And I want to show you the next steps after our evaluation, which will come up in a second. So first of all, we learned that Ibeji might be valuable as it fasten our or speed up our application development, so we can exchange the hardware and program against one endpoint that is provided by Ibeji, and the concept of digital twins seems promising to us because it gives us more flexibility than before with hard-coded options that we have had before. Thanks. Back to you, Hans and Ash.
Thank you, Christian, for that. Feel already refreshed. So I guess it's back to Ash with some next steps for Ibeji.
Okay, thanks, Hans. Okay, so the next phase of Ibeji is going to focus on creating a facade to make it easier to interact with the digital twins. And the slide shows the architecture for that. Getting a bit of an echo. The idea with the facade is to remove the need for the consumer to use to interact with the digital twin, an Ibeji digital twin service, and with the providers that it needs. So with the facade, the consumer will only need to interact with a single Ibeji digital twin service, and in this architecture, that service is the digital twin graph service. Okay, now the digital twin provider. So with the now to make this work, we had to upgrade the in-vehicle digital twin service to add additional operations and also to change some of the existing ones just slightly. But we didn't want to break the compatibility that, or dependency that people had on the existing vehicle digital twin service. So we left that there. We added, you could call this version 2 of the in-vehicle digital twin service, which we called the digital twin registry service. Okay, so now with this sort of new architecture, the digital twin provider registers its digital twins access information with the digital twin registry service, okay, instead of the in-vehicle digital twin service. The in-vehicle digital twin service is still there for backwards compatibility, but it'll be deprecated and removed at some point in the not too distant future, okay? Now, I've got details of the interfaces for both the digital twin registry service and also for the digital twin graph service on the slide. Let's focus on the digital twin graph interface for matter of timeliness. So there's 4 operations that the consumer gets to use, and the idea with this facade is it's meant to provide a graph-like representation of all the digital twins, okay, that you can navigate, that you can actually traverse the graph, you can examine it, you can modify properties, and you can also execute or invoke operations, okay, on the digital twins. And so there's 4 operations that the actual interface provides. There's a find operation, which allows you to find all the values, the digital twin values that that match a specific model ID, okay? So let's assume you had multiple seats in the car. You could find by the model ID for a seat, and it would return you all the actual digital twin values that match that. All right. The next operation is get. So this allows you that, given an ID, right, an instance ID for one of those entities, it gets you the digital twin values or value representation for that. Okay. And the idea with the get is we can now start traversing the graph by walking through each of the relationships, okay? Because relationship has an instance ID, so you can get the instance ID, like in the first case, we had the vehicle with a relationship with the cabin. You can grab that cabin's instance ID and now apply get to it to get the actual digital twin representation for the cabin, okay? There's also a set operation, which allows you to adjust the member values of a digital twin, all right? And there's also an invoke operation to allow you to invoke a digital twin's commands. The first part of this work has already been added to the repo, and we're going to continue working on that. All right, that's it. Back to you, Hans.
All right. Now we reached the Q&A session. So happy to take your questions on what we just presented for that. Any questions so far?
How does that work if you want to simulate not one seat? Can you simulate like 1,000 of them or something like that?
Yes, basically in that case you would have thousands of producers and they would register Ibeji, and then you can consume them via their IDs. Yeah.
Would it be possible to create new models? So the DTDL in the background, would that be available to also make modifications to existing models and make new ones?
Yes, basically the part of DTDL here in that part is actually having this changeability. You can build a tree or graph, whatever you need to represent your actual hardware. Yeah.
Another part, because it was the way it was represented, so it's the digital twin is like sitting in between the actual hardware and the representation, how the application is interacting. But if the hardware is not there in the development stage, would there still be working now? Or is that still like work in progress?
Yeah, that's an interesting question, and I guess that brings us to the beginning of the presentation where we mentioned that part of accelerating development. If the provider and the consumer agree upon an interface, there is no need to actually wait until the real provider is present. Like in that case we showed with the demo of the seat. You can actually start just mocking that and registering it as long as the interface is stable and you work against some contract there. Yeah.
I have a quick question. So you said that basically Ibeji is querying the hardware to ask about the detail of the hardware itself. Okay, so basically the hardware needs to be able to communicate to Ibeji that it has a certain seat setup.
Yes, so when the hardware... Ash, please. Yeah.
Can I jump in? Yeah, so the idea is, this is where the provider comes in, is that the hardware will have, will provide the capabilities, right, to Ibeji through endpoints, okay, where it will, so the idea is that that there's actually an understanding of what the actual, model looks like, okay? So the thing, the hardware will actually sort of use that model in order to, offer the actual digital twin capabilities up to the consumer, okay? And so there's going to be basic operations on it, like invoking operations, like invoking commands, getting properties, setting properties, and so forth. As Hans was saying before, you could mock out the hardware and have it, the mock be a provider, all right, where it will register the digital twin capabilities that it has to offer, right, to Ibeji, okay? And so the idea here is that you don't really need, there's this understanding of what the model is, okay? And innate with all of this is you define a model, and it's that model which is the thing that's shared between the provider and the consumer in order to interact with the digital twin, okay?
And what communication protocol are you using?
So with the protocols, we tried to be open about this. So like at the moment, the initial the initial demos that we have for Ibeji, we've actually got demos which show MQTT being used, gRPC, video streaming, and so forth. Okay, the idea here is that we didn't want to be prescriptive about the protocols, and we didn't want to be too prescriptive either about with the consumer and the provider what the interfaces necessarily look like. Okay, it's up to who's using this to actually make those decisions. The idea here is that information on the endpoints, including the protocol that's being used, is what's registered by the provider to Ibeji. Okay, and that way new protocols can be added and so forth. We did find that with the actual facade work that we've done recently, that we did need to prescribe the actual interfacing, right, for what the actual provider, the interface the provider provides to the consumer, right? And that was so that we could have the get, set, and invoke operations be, in some sense, common amongst all the providers, so that the actual consumer can then, basically make one common call across all of them. Okay, so we initially tried to start out as being as unprescriptive about this as possible, but we have tightened things up a little bit with respect to the graph facade. However, if you're not using that facade, you can use whatever protocols you want. One of the things that we're working on with the facade is to extend it to support MQTT, video streaming, and so forth, in addition to a request response like protocol like gRPC as well. Okay.